Our bodies consist of eukaryotic cells, while bacterias consist of prokaryotic cells. So, in order to treat bacterial infections, we can develop antimicrobials that only target prokaryotic cells while leaving our cells mostly unharmed. One of these targets is bacterial DNA, and we call these medications DNA inhibitors or nucleic acid inhibitors. There are plenty of processes and enzymes involved that we can target, and the quinolones and fluoroquinolones inhibit an enzyme called DNA topoisomerase. So, there are many different types of topoisomerases, but we'll be looking at topoisomerase 2, also called DNA gyrase, and topoisomerase 4. Both types of topoisomerases cause double-strand breaks in DNA, but at different points during mitosis. Topoisomerase 2 plays a role in condensing the chromosomes by making a double-strand break in the DNA so that it can be more tightly wound, causing a supercoil. When enough supercoils are induced, the DNA condenses. Topoisomerase 4 plays a role later on, after the chromosome has been replicated, where it causes a double-strand break in the DNA so the new DNA strand can be disentangled from the original. Now, quinolones were created to target bacterial topoisomerases, but it was soon discovered that by adding a fluorine molecule to the quinolones, they become more effective. So these newer medications, called fluoroquinolones, replace the older quinolones in most clinical settings. Common fluoroquinolones include ciprofloxacin, ofloxacin, balofloxacin, levofloxacin, gemifloxacin, and moxifloxacin. One way to tell a fluoroquinolone apart from other antimicrobials is that they all have the suffix floxacin. These medications can be taken peroral or via IV, but ciprofloxacin and ofloxacin are also available in otic formulations, while moxifloxacin is also available in ophthalmic solutions. Now, fluoroquinolones are broad-spectrum bactericidal antibiotics, and ciprofloxacin in particular is widely used. They are very effective against gram-negative bacteria like Enterobacteriaceae, Haemophilus, Legionella, Neisseria, Moraxella, and even Pseudomonas species. They are also effective against certain mycobacteria and can be used for the treatment of tuberculosis. However, more and more bacteria are becoming resistant to ciprofloxacin, either through mutations in the genes that code topoisomerases or through efflux pumps that pump the medication out. Another downside is that the older fluoroquinolones are less effective against gram-positive bacteria, but the newer ones, like levofloxacin, gemifloxacin, and moxifloxacin, have improved effectiveness against gram-positive cocci, especially Streptococcus pneumoniae, so they're called respiratory fluoroquinolones since they're often used to treat hospital-acquired pneumonia. The trade-off is that they're less effective against Pseudomonas than ciprofloxacin. Most fluoroquinolones are not effective against MRSA. As a general rule, fluoroquinolones should not be taken perorally together with mineral supplements like iron, zinc, or calcium pills. They'll bind to each other, a process called chelation, preventing their absorption from the gut. They're metabolized in the liver by a family of enzymes called cytochrome P450, but they are also inhibitors of this enzyme. For side effects, fluoroquinolones can cause tendinitis, especially in the Achilles tendon, where they can cause it to rupture. Due to this, they should not be used by active athletes and the elderly. Furthermore, they can damage the cartilage in growing children, so they should not be given to people under 18 and those who are pregnant. These medications also have CNS toxicity and could cause insomnia, agitation, seizures, and peripheral neuropathy. Finally, they can prolong the QT interval, leading to arrhythmias. Now, we want to make a simple and fun mnemonic that'll help you efficiently memorize and retain all these farm facts. Since all fluoroquinolones have floxacin in their name, we'll use a flock of seagulls outside a restaurant. Okay, for the older drugs like ciprofloxacin, let's use an old seagull who's sipping on a discarded drink with a straw. For the newer drugs, we can have a few young and hip seagulls. One is wearing Levo's brand knockoff jeans for levofloxacin, another is wearing moccasins for moxifloxacin, and the last one is wearing a gem-studded jacket for gemifloxacin. For indications, let's put some pink-colored gram-negative bacteria on the ground between the two groups of seagulls. Also, there are some discarded toilet paper tubes for tuberculosis. This is because all fluoroquinolones are effective against these organisms. However, the young seagulls have more purple-colored gram-positive bacteria in front of them since they have enhanced effect against these bacteria. This is why they are the respiratory fluoroquinolones and are often used to treat hospital-acquired pneumonia. To help you remember this, let's give the three young seagulls some cigarettes, which causes them to cough. Now, since ciprofloxacin is more effective against Pseudomonas, let's say that the old seagull is very classy, and he's admiring a painting of the Mona Lisa. Alright, now let's look at the important side effects of fluoroquinolones. A jogger coming out of the restaurant is kneeling down, holding his ankle, where his Achilles tendon has ruptured due to tendinitis. His legs are also covered in bandages to represent peripheral neuropathy. When he was falling, he accidentally slammed into a kid and broke his nose, causing him to cry. Since the nose is mostly cartilage, this will help you remember that fluoroquinolones are harmful to the cartilage in growing children. A mean squirrel, who's actually very cute and has a long tail, is laughing at the poor kid, and it represents long QT syndrome. The child's pregnant mother is trying to comfort him to no avail to represent the contraindication during pregnancy. An unfortunate chrome-colored cell also got squished during this incident, and this will help you remember that fluoroquinolones are cytochrome P450 inhibitors. Alright, as a quick recap. Quinolones and fluoroquinolones work by inhibiting DNA replication by disabling DNA topoisomerase 4 and DNA gyrase. Quinolones were the first medications with this mechanism, but they have been replaced by the newer fluoroquinolones. In general, they are more effective against gram-negative bacteria, but the newer fluoroquinolones have enhanced activity against the gram-positive bacteria. All fluoroquinolones are known to cause tendinitis, lower seizure threshold, cause peripheral neuropathy, prolong the QT interval in the heart, and might cause arrhythmias, toxic epidermal necrolysis, and Stevens-Johnson syndrome. But wait, there's more. Here's a mind map with all of the mnemonics from the video. Go ahead and pause the video so you can test yourself to see what you remember. Stay tuned for the answers at the end.